is 6:05. Commissioner Avila is absent today. Commissioner Chapa.
Present.
Commissioner Grimmig is not here yet. Commissioner Hisarick.
Here.
Commissioner Cato.
Present.
Commissioner Kalfani is not here yet. Commissioner Lemos is also not here. Commissioner Mandel.
Present.
Commissioner Osi is absent today. Commissioner Pack is not here yet. Commissioner Shannon.
Here, present.
That is 5 members. We do not have a quorum.
Thank you. In memory of 9/11 and the valiant firefighters, law enforcement professionals who defended our city of New York, I would like to have a moment of silence. Thank you. Is there anybody here from the neighborhood council that would want to have comment? Seeing none, is there anybody here for public comments? Seeing none, without a quorum, we'll keep public comment open until we do have a quorum, and we'll address later. But in the meantime, let's move on to the first agenda item. It is an honor to invite the Distinguished Professor of Molecular Microbiology and Immunology at the Keck School of Medicine of USC and Special Advisor to the Provost, who will speak today on viruses, including HIV and SARS-CoV-2, and her work that is supported by the National Institute of Health. Her presentation will be quite remarkable, and I'm thrilled to invite Dr. Paula Cannon. Professor, we're honored and thrilled that you could be with us today.
Thank you, President Mandel. Hello, everybody else. All right, so I'll kick in. I mean, here we are, September 2023, and we're still talking about COVID. What I thought might be helpful to talk to you about is what's happening with the mutations the virus is making, because it's been in the news a lot, and also think about what this might mean for the vaccines that I think are going to be approved tomorrow by the CDC. So let's see. Monica, yeah, can you give me the next slide? So here's just some disclosures, pointing out that, you know, I do work on SARS-CoV-2. I'm funded by the National Institutes of Health, and like many senior professors, I am also on various scientific advisory boards, and some of them I'm compensated for, but I can assure you that none of these activities are related to anything I'll talk about today about SARS-CoV-2 or COVID. Thank you. Next slide, please. Okay, so we are seeing a bit of an uptick in COVID. You probably are aware of this. The quote I have on the slide there is from the LA County Department of Public Health, I think from about a week ago, and my eyesight is I'm going to struggle to read that, so let me check on my piece of paper. And it was basically saying that we are seeing a gradual and consistent rise in COVID-19 transmission over the past few weeks, but importantly, despite this, hospitalization rates are remaining at near historic lows, and deaths are at their lowest point since the beginning of the pandemic. Next, please.
I'd ask you to move the microphone a little bit closer to your mouth.
Sure. If you could go back a slide, please. Thank you. And the graphic there that you'll see, which is just showing over a period of about 18 months, the sort of levels of COVID, including the big peak in the middle. There was the peak that we had at Christmas time, and you'll see right on the extreme right-hand side of the graph is the little uptick we're getting currently. The different colors just reflect the different types of institutions like nursing homes or educational facilities that we look at separately. So this is, again, data from LA County. Next, please. So in addition, we also, it's important that we look at COVID levels in sewage and wastewater. And this is because unlike even a year ago, you probably know that we just don't do the extensive testing that was done in the past. So it's really hard to kind of get a sense of how many people currently have COVID just by looking at the test results. And again, most of us, if we get COVID, we find out in the privacy of our own bathrooms looking at those little flow tests, don't we? So, and we don't report it. So it's very hard to know what the real rates are. So this is why sampling and looking at wastewater and sewage is such an important tool. So in the top left of that graph, you'll see that over the last 6 months, the levels of COVID were pretty consistent, and now we're seeing this uptick, and the rates going up in LA County are mirroring what's been seen across the country as a whole. And then the larger graph there, I put that one in because that shows a year-over-year comparison of the rates of COVID that we can detect in sewage. And the big red arrow is where we are today in September. And what's interesting is that the rates of COVID in sewage are almost identical to what they were 12 months ago. So, it's still not high, but we could potentially be looking at another, rise later on in the year, especially around the holidays. Okay, next please. Oh, thank you. So what drives the increases, these waves we see? Well, it's a couple of things. It's definitely our behavior, the weather. Hot weather and cold weather makes us all come inside, so we're hanging out together more, and we're more likely to give each other COVID. Also, we travel at vacation time, and in September, we often see an uptick that's due to back to school and the kids all getting back together again. But another really important feature is the fact that our immunity starts to go down. So when you get vaccinated or when you have COVID infection, especially when there's a period where a lot of people are getting infected, that's almost like a time point where immunity in the population is quite high, and then it starts to go down. And so that once you get to sort of 6 months after like a burst of activity of people getting vaccinated or a wave of COVID, you can start to see another increase because people's immunity is going down. But I guess the thing we worry about is, what about the virus? Could these new waves of infection actually result from new properties that the virus has developed? So we talk about, the virus mutating, and we talk about new variants of the virus emerging. And the concern is that what if, a new variant of COVID emerged that had an increased ability to infect us and be transmitted, or was even better at overriding our immunity? Could that itself actually give rise to a new wave? And that's kind of like the sort of scenario we worry about. Next, please. So here's one of my favorite cartoons, which really just kind of reflects, I think, what the virus thinks of us. Here's COVID, the one on the right, looking quite harmless, and the best weapon we have, which of course is the vaccines. And the cartoon is really showing that as the virus mutates, it may be that the vaccines we have start to become less effective against it. And so this is why we worry about having these mutations. Next, please. Yeah. So, just a little bit of terminology for you. I thought I'd put this up because we often hear about phrases such as variants of concern. So this reflects how the World Health Organization classifies different COVID mutants or different COVID variants. And they're in a sort of an increasing level of concern. So first of all, they have what they call variants under monitoring. And so this is when new mutations of the virus arrive and a new variant is observed. And people, scientists, people like me, I guess, look at the mutations and we think, I'm a little concerned that they may change the virus's characteristics, including its ability to transmit, the severity of the disease it causes, or even its ability to escape from some of the drugs and the monoclonal antibodies that we have. Variants of interest are the next level up. These are mutants of the virus that we actually know the mutations really are known to affect the virus characteristics, and/or we are seeing real epidemiological impacts. We're seeing waves of the virus in sort of different countries, for example. And then at the top of the tree, we have the variants of concern. And these are the ones we worry about because they have markedly different characteristics. They either show a real increase in transmissibility or an increase in the severity of the disease that they cause, or we see decreased effectiveness of public health measures, or the PCR diagnostics we have don't work, or the vaccines don't work, or the therapeutics don't work. Any of those kind of possibilities would profoundly change the damage that these viruses could cause, and that's why the World Health Organization calls them a variant of concern. Okay, that's the terminology. Thank you. This is a little sort of relationship graph showing the main variants of concern that have arisen since COVID first appeared. And on the left, you'll see the family of variants called things like Alpha or Delta. I feel like, does anybody remember Delta? That was the last one before Omicron we were worried about. And so what I want to point out is all those guys on the left, although things like Delta and Alpha and Gamma are all in sort of distinct little branches of the family, they're still all pretty related, and they all seem to be emanating from the sort of like a central locus. But then over on the right, this is just showing you kind of like how sort of really out of the blue Omicron was. Omicron is profoundly different from anything that went before. And Omicron has sort of continued to evolve and make new Omicron variants. So you'll see that the sort of the branches are all kind of, sort of, they're still in the same group, but they're kind of moving further away. So it's really interesting, because when I look at that, I think, whoa, Omicron, it's almost like we should have just called it COVID-22 or something. It's like a really different virus, and it's quite different from all the other variants that came before it. And the other graph I have on there just shows you the waves of these different viruses, these different variants as they hit California from 2021. So the sort of the teal color in the middle is the Delta virus wave that we got in the fall of 2021. And then from sort of the holiday period in 2021, everything has been brown, if you like. Everything has been Omicron. So every other variant of the virus has basically gone extinct. And all we are left with is Omicron, because Omicron is a very successful virus. It kind of likes us, it really likes us. It's hanging around. Next, please. All right. I did warn you, I'm a virologist, so I promise only a little bit of virology. But I wanted to give you some insights into why Omicron was such a game changer. So the little cartoons I have up there, first of all, that's a cartoon of the COVID virus, SARS-CoV-2, and it's covered in these spikes. I think everybody's very familiar with the spikes by now. And the second cartoon is showing a sort of a blow-up of the cartoon of a spike, and right at the tip of the spike is like a little piece that we call the receptor binding domain, or RBD. And this is a really important part of the spike protein, because this is the part of the spike protein that latches on to the receptor on the surface of our cells that allow the virus to infect. And when we make antibodies, in theory, antibodies can recognize or stick to any part of the spike protein, but the antibodies that happen to stick to the receptor binding domain, it's like they put a little cap over it and they stop it working. So we say that those antibodies neutralize the virus. We call them neutralizing antibodies, and they're the best type of antibodies to make. And then, of course, the problem is that if the virus is not stupid, and if you like, it can play chess. So if we start to throw antibodies at it, either the antibodies we make ourselves in response to a vaccine or an infection, or if we take an antibody as a therapeutic, a monoclonal antibody, we're sort of challenging the virus. We're sort of saying to it, hey, we're trying to neutralize you. And sometimes the virus makes a chess move and says, okay, I have mutated. I've mutated this little part of my receptor binding domain that the antibody normally sticks to, and now I'm resistant to the antibody. So this is the basis of how mutations and variants overcome sort of pre-existing antibodies and can overcome our immunity. And then the final thing I want to point out on this slide, in the little red box, so this is just a schematic showing all the different mutations, the way that the different waves of SARS-CoV-2 have been different from the original strain that came out of Wuhan. And so the little black marks are just showing the differences, for example, with the alpha or the beta or the delta strains. And in red, I'm highlighting all the mutations that we saw in Omicron. And you'll see straight away that it's like Omicron understands the game. Omicron had all these mutations, especially in this receptor binding domain region. And this is one of the reasons why Omicron was just able to overcome our immunity and why it's so infectious and why no matter how many times you've had it and how many times you get vaccinated, you can still get it again. It's very good at immune evasion. Okay, I think that's probably the last of the virology slides. Okay, all right. So why does SARS-CoV-2 mutate so much? And this surprised us in the virology community because we weren't expecting this to happen. It's a coronavirus, and they normally don't mutate. So the first thing I'll say is, you know, it actually hasn't mutated a lot, but we've had at least 770 million infections by SARS-CoV-2. So even if it only did this incredibly rarely, there's enough people infected to give it lots of opportunities. Secondly, as we know, this is a virus that is very new to humans. You know, it's only been in humans since 2019. So it's kind of still finding its way and optimizing its design. There's lots of opportunity for it to get better at being more infectious, and to get better at being more resistant to our antibodies. Another thing that can happen is that sometimes you can be really unlucky and you can get infected with 2 strains of COVID at the same time, right? I don't know what you'd have to do for that to happen. And so if you have two strains of the virus and they're different, the virus can actually make a sort of a mix and match virus, and that can create an entirely new virus as well. And then finally, one of the things that we know is a feature of SARS-CoV-2. In most people, when you get it, you have it for sort of 5 to 10 days. But if you are immune compromised in some way, if you have a weaker immune system, the virus can actually hang out in you for weeks and months. And so the longer the virus is in somebody, the more chances it has to evolve mutations that can let it escape antibodies, for example. So, and this is what we think. We think that Omicron, with all those mutations in the receptor binding domain, we think it probably arose in somebody who was immune compromised and therefore had an infection for a long period of time. Okay, next please. Okay, oh lordy, I always hate looking at these types of slides. This is just showing you what's happening right now in sort of the beginning of September in region 9 of the country, which includes California. And you'll see, first of all, you see all those different colors, which just reflects how many slightly different variants of Omicron are floating around right now. The top one at the moment is one called EG5, or its sort of shorthand name is Eris, and then we're also seeing a lot of the XBB 1.5 still, which is the sort of the bright blue one, and that was called Kraken, which I think is a great name. So there's lots of these different variants, and sometimes they kind of compete with each other, and we see one coming to the fore, and then another one takes over. Next, please. You can also see these waves of these different variants when you look in wastewater and sewage again. So this graph is just showing you some waves of different Omicron variants from December 21 to the present time, and you'll see we started off, first of all, in orange. We had a big wave of BA1, then BA2, and then sort of last fall and winter, we got BA5. And that was kind of the reason why the vaccine we had last September, I believe it came out, that was a combination of the original spike protein from the original Wuhan strain, but it was also mixed in with the BA5, and the reason we chose BA5 was because that was the prevalent virus at that time. And then since then, we've gone through XBB 1.5, and now we're starting to get EG5 5 as well. So wastewater, again, it's a really important way that we can monitor these waves and see what's happening. Okay, next. So I thought I'd give you a couple of slides on this guy, BA 2.86 or Parola. And this was making the news a couple of weeks ago and was actually a little bit scary. I'll explain why. Next, please. So yeah, so this is just some of the headlines I picked up. You'll see, people, the media was very interested in this. A new COVID variant, BA 286. Should you be worried? The former FDA boss says he's very concerned about it. It's causing concern. I got lots of phone calls from people about BA 2.86. Next, please. Why were people so concerned? Well, first of all, there's hardly any BA 2.86 at the moment, but it has been detected at very low level in 10 countries, and actually I believe as of today, I think it's in 10 US states, and it's done all this in sort of since it was first reported at the end of July. So the fact that it was detected in multiple different countries suggests that it has been sort of spreading around the world kind of undetected, and now it's just getting to the level where we're starting to pick it up in samples from people and in wastewater. Okay, but that still doesn't explain why people are freaking out about it, but I think the next slide will. Okay, so here's this schematic again of the receptor binding domain. So if you just focus on the bottom, you'll see what I've put there in the little black dashes at the top. That's a reminder of the changes that happened in Omicron. This was Omicron BA2 compared to the original Wuhan strain of the virus. So you'll see multiple changes and all concentrated in this critical receptor binding domain region. And then when you compare BA286 even to Omicron BA2 in red, that's all the changes that we see. So the large increase in mutations, the large jump between BA2 and BA286 is very reminiscent of the huge changes that when Omicron first appeared. So this is why people were concerned. The question is this like Omicron 2.0, a new variant that is so profoundly different that we're going to have another really big wave and maybe our immunity won't be very good against it, and this will be, just really a problem. The little graph on the right-hand side, go back please, just shows again that here you've got BA286 right up in that top right corner in pink. It's very different from, for example, EG5, which is the current prevalent strain. So it's really profoundly different. Okay, next please. All right, so here's the questions we have. Is BA 2.86 more transmissible or more virulent? Have these mutations done that? And is this why it's now starting to spread throughout the world? Is it more antibody resistant and therefore more likely to break through the protection conferred by our antibodies, which we get either from prior infections and or vaccination? And what, if any, are the implications for the new fall booster vaccine that's about to be rolled out? So I have some good news. Next slide, please. And this has really all happened in the last few days. So, let's see. So first of all, labs around the world rushed to do an analysis of BA 2.86 to find out if they thought it was going to be a problem. So it's a complicated slide, but this came from the lab of Dan Baruch, who's an investigator at Harvard. And what he's showing here along the bottom is just lots of different variants of Omicron, and right at the extreme right with a little pink star above it, that's BA 2.86. Now what all the dots do is they are showing, if you like, how effective antibodies in people's blood are going to be against these different variants of COVID. So basically, the higher up the graph the dots are, that means that the antibodies are working better. And so what they did was they took blood from a bunch of people on the left-hand side 6 months after they had the last bivalent booster. And then on the right-hand side, they took blood from people who didn't have the bivalent booster but had been infected recently with COVID with one of the XBB strains. So it's the two scenarios we get. You get immunity from being up to date with your vaccines, or you get immunity from being infected. I know which one I prefer. And so the good news is that BA 2.86 kind of looks like everything else. You know, it's not the most resistant and it's not the most sensitive. It's kind of solidly in the middle there. And so what that tells us is we think that as long as people, you know, are reasonably up to date with their immunity, and even at 6 months out, BA 2.86 is not going to be any worse than anything else in terms of being able to break through our immunity. Next slide, please. There's also good news coming from Moderna and Pfizer, who have been developing the new vaccine that's going to be rolled out, you know, maybe the end of this week. So here's a press release from a couple of days ago from Moderna. And what they've been doing is they have a group of individuals who they gave the updated fall booster vaccine to, and then 15 days later, they took blood from these people and they tested the ability of the antibodies they make in response to the vaccine to be protective against lots of different variants of COVID, of Omicron. And they found that, similar to the data I just shown you, that BA 2.86 is really no more resistant. It looks like it's going to be just as sensitive to the antibodies that people make in response to this updated vaccine as some of the other variants they've looked at. So I think these two things together have kind of, you know, allowed me to sleep at night, despite all the mutations in BA 2.86. Okay, so just a couple more slides to go through. So first of all, an update on what's happening with vaccines. So reminding everybody that the initial vaccines we had, you remember all those, 1, 2, 3, 4, I can't remember how many I had. They were, for example, if you got the RNA vaccines from Moderna or Pfizer, they contained the information to make a spike protein in your body, which you will then make antibodies against. And they were based on the spike protein from the original Wuhan variant. Last fall, the decision was made to update the vaccine, and we ended up with these so-called bivalent vaccines because they contained information to make two different types of spike. The original Wuhan strain, to kind of hedge our bets because we know that that works as a vaccine, but then they also included information to make the spike protein from the Omicron BA.5 strain. And if you remember, I was pointing out that this was the dominant one last fall, so it was good because the vaccines we got last fall, at least 50% of the vaccine, if you like, matched the circulating strain. So then in the summer, in June, a panel from the FDA recommended that when we think about the vaccine we're going to get this fall, that it should be updated. And, you know, they took a good guess, a little bit like people who make flu vaccines each year did, and they suggested that the updated fall boosters should be a single spike protein, and it should be based on XBB 1.5, which is Kraken, if you were remembering that. And they chose XBB 1.5 because although it was the dominant strain in the summer, everybody kind of figured out that by the fall, XBB 1.5 is probably not going to be the dominant circulating strain just because of these waves we see all the time, but that everything else was kind of like a sort of friends and family of XBB 1.5, so that things would be pretty similar. And again, if you look at the sort of the graph on the right-hand side there, down at the bottom in the sort of the red and orange, you've got XBB 1.5 and showing it's still closely related, for example, to EG 5.1. So XBB 1.5 seems like a really good choice because the viruses we currently have are still, you know, close cousins of XBB 1.5. And then, as I said, the Updated data that Pfizer and Moderna have presented to the FDA shows that people who've received this new fall vaccine are making antibodies that look good against the current variants, including EG5. So the expectation is that the CDC, there is a meeting of their advisory committee tomorrow where they are expected to approve these vaccines, and they should be available in chemists' pharmacies very quickly. I will also add that there is a third vaccine we are expecting to have out this fall made by Novavax. It's a different technology. It's not an mRNA vaccine. It's kind of like the spike protein itself embedded in a sort of like a little, we call them nanoparticles. So for people who don't want to have an mRNA vaccine, this is an alternative technology that also looks very promising, although I don't think it's quite ready to be approved this week. Okay, next please. So here's my final thoughts. See if you guys have been paying attention. So the circulating variants of COVID are still Omicron. And it's interesting, and it might reflect the fact that the virus really likes being Omicron, and it's kind of evolved into, it's kind of gone down a corridor, and it might actually be stuck there, and it might be moving towards a sort of an endemic endgame. However, when we see things like BA.2.86 kind of apparently coming out of the blue with all these huge mutations, this suggests that the virus can still evolve in an unseen manner and throw up something that is very, very different. And it's likely that this might have happened in, for example, an immunocompromised person who had a prolonged illness, or alternatively through co-infections and recombinations in people, or even by evolution in animal hosts. We know that SARS-CoV-2 is now endemic in a lot of mammals, including deers, for example, and it could be that the virus mutates differently in those animals and then jumps back into humans, and it's very different. We don't know where BA.2.86 came from yet. The third point, wastewater monitoring is a really good predictor of new waves of infection and new variants, especially when we aren't doing large-scale testing anymore. And the appearance of BA.2.86 tells us why we need to keep doing this type of monitoring. As I just said, the choice of the new fall vaccine, which is based on the XBB 1.5 Kraken spike, looks like it was a very good choice. And then finally, just to make the point that I've been talking only about antibodies, and especially neutralizing antibodies, and they are, if you like, the first wave of protection against you getting infection. But even when they can be partially escaped by new mutants, or even when the levels go down because it's, say, 6 months since you were last vaccinated, even if you get a breakthrough infection, the good news is that our immune system makes a much broader response. There's lots of other components to an immune response, and that's what's protecting people against severe disease, even for these, very distinct variants. So I think my last slide. So here's my recommendations, and I'm not a medical doctor, and I'm not a pharmacist. I'm just a girl virologist. But here's what I say to my friends. So pay attention. Be aware, is COVID going up? At the moment it is, so that means you're more likely to get it than you were last month. I would say to people, be prepared to test if you have any symptoms, and I'm sorry, it's September, so I don't really think you're going to have allergies. If you've got a runny nose, you should suspect COVID. So having COVID tests in your bathroom cabinet is just a sensible thing to do, and if you get an upset stomach, a bit of diarrhea, a cough, a headache, a fever, anything, suspect COVID and test for it. If you are infected, nothing's changed with the recommendations. You should isolate yourself, wear a mask if you have to go out, and if you are eligible, take Paxlovid. It's a profoundly effective drug, and we're seeing evidence now that not only does it reduce symptoms, shorten the severity of the infection, it is also providing protection against long COVID, which is still one of the things we worry about after people have COVID. And then I would say to people, get the new fall vaccine. The recipe looks great based on XBB 1.5, and especially if it's been more than, say, 3 months since you were last infected or vaccinated, you can get that now. Okay, and with that, I'm happy to clarify anything or take any questions.
Thank you for the wonderful overview and update. We've had presentations beforehand on virology of COVID, and so this is a great reminder for us all and for the people of the city of Los Angeles to be vigilant. A few questions. One is, you talked about the little mutations, especially in the little box. Are each of those little hatch marks, are they one nucleoside alteration, or is it a structural alteration in the
Right.
the virus itself?
So it actually reflects an amino acid change. So it's a change at the nucleic acid level. The virus has RNA, but it actually makes a structural change in the protein. And not all of those mutations do things we understand. Some of them make the virus stick to its receptor better. A lot of them make the virus resistant to antibodies. And that reflects the fact that, you know, this virus now, whenever it infects somebody, it very rarely gets a naive host. Most of us have had COVID or we've been vaccinated. So already the virus is up against antibodies. So there's just a very strong selection pressure to have any mutations that can bypass antibodies, and including the monoclonal antibodies that were so effective as therapeutics. For the longest time, really, most of those just no longer work against these new variants of the virus.
That was going to be my next question, actually. Are they making new monoclonal antibodies
Yes.
to the Omicron variations?
Yes, and again, I think it's the analogy I said earlier. It's kind of like a chess game, isn't it? The virus makes one move, and the drug companies go, "Dang, now we need to make a new, and we need to find a new antibody that is still effective against this new variant." The good news is that now we have large libraries of different antibodies. Academic labs and biotech companies understand that this is something we want to do. So having effective monoclonal antibodies still in our arsenal of therapeutics is definitely important, because this is a way you can really reduce the severity of the disease in people at risk. So that, combined with the good drugs we have, such as Paxlovid, I think that's what we want. We want to be able to offer those to people who do still get infected. Because as we know, it's although COVID is probably going to be mild in most of us if you've been vaccinated or previously infected, it is not mild in a significant number of people, and it is extremely serious in an unacceptably large number of people. So we do need these additional therapeutics.
And you mentioned that worldwide, approximately 770 million people have been infected, but we know that some countries, the PRC being one, or India, especially in the rural areas, might not have the most accurate data.
Yeah.
And so, do we really believe it's 770 million, or do
No,
we think it's more like 2.5 billion?
No, I'm being conservative, so that's really they're the ones we know about. And what I can't tell you is how big I think the iceberg is. I really don't know what the real number would be, but it's certainly probably significantly higher than that. I mean, even in this country we know of, I think it's over 1 million now. I think it's about 1.1 million. No, sorry, it's over 100 million. It's 120 million. I'm getting my numbers wrong. We know of 120 million cases. It's 1.1 million deaths. I mean, the reality is, that's a third of the country, isn't it? I think it's much higher than that. Again, I think most people have probably had COVID by now. It's really, especially with Omicron, it's so extraordinarily infectious.
Right, so that was the next question I was going to have was, so with the EG5, we have a significant number of people in America and in LA County who have not been vaccinated because they don't want to be vaccinated. And a lot of those people have caught one of the viruses, or multiple times have caught a virus.
Yeah.
Is the reason that the hospitalizations have not really increased as much and the ICUs have not been overwhelmed by these waves that you were showing us on the prior slides, is that because the EG5 might be little bit more infective, but a little less
Yeah.
aggressive in its nature on our lungs.
I think that's probably true, but I think it's a minor contribution. I think that the main reason that hospitalization rates are low is again just because everybody's now, well, I always say to people, you either voluntarily go and get vaccinated, or nature is going to vaccinate you through infecting you. So when the majority of people will have antibodies against COVID is how I think about it. And so that means that for most people, the virus is coming into somebody who's already got immunity of some degree, and that's what's sort of holding this down. It also, when people who already have some immunity get infected, they get a milder disease in general. The disease is shorter. So there's all sorts of reasons why the symptoms are less severe and there's less hospitalization. It's really hard to tease out, is it changes in the virus? Because, how are you going to do that experiment? I need a whole bunch of undergraduate student volunteers who've never had COVID and expose them? No, I don't think I can do that. It's really hard to know what the true infectivity of EG5, for example, is in somebody who's never made antibodies. When you remember back to 2020, the first waves, and even 2021, when people were getting COVID, people were really sick, and it was very scary. So now, I've had COVID twice this year. It was my first 2 times, and in both cases, it was almost like, okay, finally I got COVID. I had no symptoms either time, which is just testament, to the amazing vaccines. So it's changed for me. It's not something I'm terrified of getting anymore. But I don't know that I would say that's because the virus is less severe. It's just really hard to know that, yeah.
And can we say then, either because of the vaccinations or because of natural infective immunity, that we have kind of a partial herd immunity?
Yeah, I think that's a reasonable way to think about it. In the same way that, we have sort of partial herd immunity against other coronaviruses, that's the type of virus this is. Every year we all get colds, and some of those are caused by other coronaviruses. And, you can sort of think about that. You can think if we'd never had, I don't know, the 50 colds we had as children, and we were getting a coronavirus cold for the first time, maybe that would look very different, if you get that for the first time when you're 50, as opposed to multiple times through daycare. So these viruses are, the symptoms they cause and the severity, it's always this dance between characteristics of the virus, but also characteristics of the host and the pre-existing immunity you have.
The natural history of coronaviruses in general is that as time goes on, that they become more infectious and less aggressive.
That's been yes, in the past that is true. There's, natural selection will select for things that are more infectious, which tends to be viruses that live in the upper part of your respiratory tract, which is probably a nicer place to have a virus than down in the lower part, where you're more likely to get, significant symptoms and pneumonia. So there is a sense we expect coronaviruses to become sort of more infectious, but milder. There's also this idea that if you have a virus that gives you a little bit of a runny nose and makes you sneeze, but doesn't make you skip work, that virus will have an advantage because you can go and share the gift of the virus with all your co-workers as well. So this is what we've seen in the past with other viruses. And, SARS-CoV-2, I think it's still too early to say whether it will conform to that pattern. I mean, we hope it will. We sort of hope that we are moving towards a virus that is endemic, that everybody either gets as sort of a young child where your immunity is pretty robust, or it becomes one of the childhood vaccines that you get. Maybe, a little bit like we deal with influenza, recognizing that it is still a virus that can cause a huge amount of problems for more vulnerable people, especially older people. I mean, the reason we have flu shots every year is both to protect individual people, but it's also a decision we make kind of as a community, that we take flu shots so that we don't get flu and pass it on to somebody who's more vulnerable. So I hope that we can start to think of COVID vaccines in the same way. They will provide you with personal protection, but it's also kind of doing your part to provide community protection and stop these viruses going to people where they can really, cause a huge amount of illness.
Great, thank you. Commissioner Shannon, you had some questions.
Yeah, so the fall vaccine, which is kind of fashioned around the XBB 1.5,
Yeah.
can we predict how effective that will be against the B2.86 variant? Because I know you said they were cousins.
Yeah.
Can we predict how effective that is, or we kind of just wait and see?
Well, we do have to wait and see, but I think the data that came out, I think, 2 days ago from Moderna looks very convincing. So again, what they've done here is they had a clinical trial where they'd taken people, I think they had 50 plus people, and they gave them the prototype of their fall vaccine. And then what they do is they can't infect people with COVID. That's kind of that's not what they do, but they can take their blood and they can add their blood to the virus and see if the antibodies in the blood of these people who've been vaccinated, if it's able to stop the virus. And they did see that the people who got the new vaccine, their blood had sort of 10 times higher levels of antibodies that recognize the current circulating strains, including also when they tested it against BA.2.86. So that's good sort of real world data, but we will only know, I guess, in the future when we compare the rates of new infections. Maybe we look at, around the holidays, and you always see this difference between people who've been vaccinated recently and people who haven't, in terms of who gets SARS-CoV-2. So I would say to people, even if you've been vaccinated in the past, you got vaccinated with, COVID-19 Wuhan strain. That is almost extinct. The virus we have now is Omicron, XBB 1.5, and friends. We have a new vaccine that is tailored to Omicron XBB 1.5, which is, the virus that you're going to encounter. So if you want to protect yourself and kind of enjoy traveling over the holidays and things like that, this is the vaccine to get now.
And I would say, just anecdotally, my daughter just went back to school, and like half of the 8th grade class,
Yes.
the second week had COVID. My daughter's son went home today with COVID with my daughter, who I haven't seen. So I think I'm okay
it's
for
really,
now, but
it's a back to school virus, it looks like. I mean, we don't know what it will settle down into doing. Different viruses have different sort of seasonal patterns. We all know flu isn't something you get in June. Flu is something you get in the winter. We still don't know what COVID is going to do, because it's still, there's so much of it, but maybe in the future it will settle down to being a more predicted seasonal virus. I mean, it certainly seems to like the holidays. I think the last couple of the holiday periods, especially around Christmas time, we've seen, and New Year, we've seen big upticks, and maybe it will continue to do that. But back to school, definitely, there's always going to be a little COVID uptick as well.
So can we predict that we might go back to masking? Like, at what level do we hit?
Yes, that's an interesting question, isn't it? So the way I think about that is a couple of things. So masking is good but not great in terms of protecting you. It adds an extra layer of protection. If I had to choose between being vaccinated and wearing a mask, which I know is a hypothetical, I would choose a vaccine every time. I think also, we use masks for two ways. One is if you are personally vulnerable, or you're living with somebody vulnerable, or you need to travel, or there's some reason you really don't want to get SARS-CoV-2, then wearing a mask yourself makes sense. But requiring sort of everybody to wear a mask, I'm not sure that we need to do that at all at the moment, because we did that as part of the public health measures to protect our hospitals, really, and to respond to the extraordinary public health emergency that the initial waves of COVID produced. And we're not seeing that at the moment, and fingers crossed it stays that way. The sort of things that to me would bring back a justification for all the public health mitigations we can do, including masking, would be if we started to see our hospitals being overwhelmed again, because we all know that it's not just about the terrible burden on the people who actually have COVID in the hospitals, but it's all the ripple effects and the knock-on effects and the huge disruption to healthcare delivery. So that would be a reason for me. Masks are just, one of the options we've got. I would hope that by now we've sort of learned that another thing that is really effective is ventilation. So for example, I can tell you I run a research lab. We have a large open office. The door is always wide open. We have an air purifier going all the time. And because of that, we feel comfortable not wearing masks. Also, everybody in my lab, we're a virology lab, so if anybody had any symptoms, they would stay at home, they would send me an email, and I would say, okay, get a test. Please don't come in for a couple of days. So these are the things that we do in my particular workplace setting that allows us to feel, pretty safe in the absence of requiring everybody to wear masks. Yeah.
Okay, thank you.
Commissioner Hischer.
Okay. Thank you. Thank you for preparing such a nice handout. That's really helpful.
Thank you.
In your final thoughts here on wastewater monitoring, you say we should keep doing this. Is there a question about keeping doing it? And is it the health department that does it?
So I don't know the answer to that, and I don't know any specifics about how that's done in LA County. But really, I just wanted to make the point that we no longer do the sort of widespread surveillance through PCR testing that we were doing in previous years. And so because of that, we're a little bit blind about what's happening with COVID. But sewage and wastewater gives us this incredibly important information. So I just, hopefully there's still funding for whatever agencies are funding that to do that, and people understand the value of it, because it may be that something new emerges. And again, the fact that as soon as BA 2.86 started to be seen, people instantly recognize the potential importance of it, and we could quickly look at it and address it. That, I think, is a good example of why we need to keep doing this monitoring and just kind of know the enemy, really.
Were those data that you used to get prior to taking a look at this, the wastewater monitoring, or is that something that's only come into the scene recently?
It started being used in 2021, yeah. But it really wasn't done widespread at all. I must admit, I'm really surprised at how well it works. At my own university, for example, one of the ways we assess whether or not there might be an outbreak amongst the students is we sample it's kind of gross to think about this, isn't it? Well, wastewater is a lovely phrase.
Yeah.
It's not water we're sampling. We look at the wastewater that comes out of, for example, the residence halls, and if we see any increase in signal from a particular residence hall, we can let the students in that hall know that somebody or multiple people have COVID in there. So it's a nice tool for surveilling, things like universities as well, so we can see if infections are starting to peak.
Is that funded by the university?
Is what, sorry?
That sampling is funded by the university to look after the students?
Yeah.
And I don't know if the president knows, for our county if it's a county-funded?
Yeah, currently it's county funded. In the United Kingdom, they were doing it in 2020. It
It's
took
true.
County Los Angeles about a year before we started doing it. That's probably a mistake on our part. We should have been doing it in different locations within the county. And I think we should have done that much earlier than waiting a year.
It certainly gives you geographical information as well about where outbreaks might be. I mean, again, maybe not so critical at the moment, where we don't see these sort of pockets, but of course, as you remember from the early days of the pandemic, we really saw huge differences geographically in terms of where COVID, where the hotspots were, and we could have had eyes on that even in the absence of testing.
And the methodology of getting those data are pretty consistent as far as we know?
The methodology, did you say? Sorry.
Yeah, I mean, how do they
Yeah.
do it? Are they all
Yeah, they
presumably-
have standard sets of, it's all based on PCR, and there's sort of standard ways of doing that. So, I mean, again, I was just really struck. If you remember, one of the slides I showed you was the wastewater, the levels of COVID detected in wastewater, and it's something like, I forget what the units are. It's like, number of virus genomes per mil of sewage. And the LA County data is just superimposable on the sort of the national data. So it's really a very robust methodology.
Thank you.
Thank you, Dr. Cannon, for your presentation. You mentioned that variants jump onto animals and jump back to humans, that sometimes is not detected. My question is, how concerned should we be about these variants jumping onto livestock or animals that we
Right.
consume and we mass produce for consumption?
Right.
That's always I think.
So that's an
Question.
interesting point, and it actually, I think a good parallel example of that is the way we monitor for flu in poultry. One of the types of influenza that we're very concerned about is what we call bird flu. Normally, so far bird flu has been in birds, but it's a particularly nasty strain of influenza, and we really worry what would happen if these aggressive pathogenic bird flus jumped into humans. So we monitor poultry in this country and other countries for emergence of bird flu, and when we see an outbreak of bird flu, we cull the chickens, basically. So in terms of parallels with COVID, I'm not aware that it infects or causes problems in livestock. I mean, we know that COVID infects, cats actually, lions, tigers, and pet cats, and there is definitely a reservoir of COVID in deer. Is it the white-tailed deer? I forget the actual species, but we are seeing COVID in deer. In Europe, there were concerns of COVID being in populations of mink. I don't know if you remember that. I think that was in the Netherlands, and so they culled huge numbers of mink from mink farms. So I would say we are concerned about COVID infecting animals, us not knowing about it, COVID evolving in those animals, changing into something which is a new variant with new characteristics, and then being reintroduced into humans. But in terms of livestock, I don't think that's a problem. No.
Thank you.
I'm trying to walk a line between giving you all these possibilities, but also I don't want to fearmonger. And the good news is people are sort of monitoring this and yeah.
One of the interesting, on your third slide, when you showed the wastewater growth from the first year,
Yeah.
2020, there's two big rises early on. It's interesting, we didn't really see those rises as much here in Los Angeles as they did elsewhere in the country, in
That'd be
the New York metropolitan area, Connecticut, et cetera, or up in Washington State. Obviously, they had a lot more when we were not really seeing it then. It is an area where we can watch and see the wastewater and see different trends, so that we could put more resources when we had limited amount of protection
Yeah.
We could send more to one area than another as opposed to just doing it by population of states or counties, whatever else. It's probably better to send it where we know.
Yeah.
So using the wastewater analysis is really a better way to go than looking at hospitalizations and or numbers of people have a positive test, because a lot of people get positive and don't test.
That's right. Yeah. Most COVID infections now are, kind of only recorded in the privacy of people's bathrooms, really, aren't they? They're not, uploaded to a database. Guilty myself as well. I must admit, last time I tested positive, I was like, oh, should I be reporting this somewhere? I'm like, well, I'll tell my family. By the way, guys, Mom's got COVID again.
Well, 40 years ago, to have a pregnancy test, you had to go to a doctor's office.
Oh, wow.
And now everybody does it wherever.
Yeah.
Any other commissioners have questions? Dr. Kato.
For the BA.2.86 virus that sort of comes out of the blue and shows up in 10 countries, so when you discover a variant, I presume it's sequencing or
Yes.
something that lets us know.
Yeah.
What kind of incident has to happen before you sequence the person's infection?
Okay, so the reason, so I guess the way I would think about it is that, we've got all these different variants, and there's hundreds, if not thousands more. It's almost like every person who gets infected will probably produce, a variant, even if it's just one amino acid different. But for something to then rise to the level where it can be detected by the types of surveillance that's done, for example, some hospitals in some countries, especially, the United Kingdom, as an example, will just sort of randomly sequence some material from people who've got COVID. So you have to kind of, your virus has to sort of get to a certain level just in the population statistically to make it likely that it would be captured. So there's probably hundreds of thousands of slightly different variants that are being churning through sequencing machines all over the world, and it's only when the same one sort of pops up in multiple places that people go, wait a minute, we've seen this one somewhere before, yeah? I mean, I say people, of course, it's a machine. And so BA 2.86, I tell you, it's just rolling off our tongues now, isn't it? BA 2.86 got people's attention for two reasons. One, because it was seen in at least, 10 different countries, but because of the profound constellation of these mutations in the box, in the receptor binding domain, which was really, rang some alarm bells because nobody had seen anything quite that different. And again, as I think I mentioned, the changes in BA 2.86 compared to the Omicron that's floating around now, we're on a par with the differences between Omicron when it first arose and everything beforehand. So people were really worried that, oh boy, the virus has done this trick again. Omicron was the strain when it first happened. Let me see if I get the dates right. We're in 23 now. So it was not this past winter, but the one before. So that would be the 21, 22. Yeah, I think I've got that right, sort of holiday period. That was the first time Omicron came around, and it ruined everybody's holiday period because it was incredibly infectious and a lot of people got it. Yeah. So we were just really concerned that this might be what's happening again with 286. But so far, because it looks like it's not really any more resistant to antibodies than the current circulating strains, our expectation is that the pre-existing immunity people have, combined with the new fall booster, will give people an immunity that can, that won't let it form another, big wave. But fingers crossed.
Yeah, I think, some of my goal in the question is to take out some of the spookiness given to an out-of-the-blue virus, right?
Yeah.
I think the idea is what you said you see them in like 10 disparate countries. It's not like a nucleus that spreads rapidly.
Yeah.
And so I interpret it also to be a virus that wasn't particularly severe in most people that received
Yes.
it. So they traveled around and had it. And then somewhere where, the threshold of infection achieved a level where you're getting people with symptoms that then warrant sequencing, you find
Yeah.
them in these 10 disparate
And
places.
I think also it's one of those things that we're now seeing it because we're looking for it. So the word went out, whoa, here's this new strain, somebody's seen it's got all these mutations, whoa. And so people then go back and look at their data and they're like, oh yeah, hey, yeah, we got it. So it's really still, we're sort of freaking out about something that is at vanishingly low levels. But what we are looking for is, first of all, will our antibodies be able to control it? And so far the data says yes, just as well as it can control anything else. But the other thing we will watch is those levels in countries. If it sort of stays low, if it stays as a sort of a minor variant, we'll forget it. But if it starts to increase in frequency, do you remember the graph with all the different colors? If we start to see a color that is BA 2.86 and it starts to grow over time, then that says it has a selective advantage. There's something about its characteristics that's making it more transmissible or more able to overcome our immunity, and that's when we pay attention to it. But so far it's still kind of underwater in terms of numbers. It's extraordinarily rare at the moment. I hope it stays that way. So again, I don't want to frighten, it's one of those things, the only reason I bring it up and talk about it is because it had been in the news in the last couple of weeks. So when you asked me to talk about variants, I'm like, well, I'm going to talk about the flavor of the month. But I hope that, a month from now, people will be BA 2 point what? What was that? That was a nothing burger. Let's hope it's a nothing burger.
Any other commissioners with questions?
Yeah,
Please, Dr.
I'll
Chop.
go with one more in the genetics. So, with flu, it's like segmented genome, so it makes a lot of sense that you have these huge shifts in what it looks like, especially with co-infections, and you mentioned that you get this recombination events. With SARS, or with, COVID, it's a single
one.
genome,
Yeah.
and, you can only have like a genetic drift almost, right?
That's
it's only
right,
a couple of
yeah.
changes at a time. But yet we're seeing these wildly different impacts in its
Yeah.
ability to be infectious, et cetera. Why does this virus seem to have a more elastic genome than other RNA viruses?
Yeah, so again, I think as a virologist, the way I think about it is, and again, this is one of my slides, is I actually, we talk about it being, more mutagenic, mutating faster than we expect, and I'm not sure I think it is. I think it still hardly mutates. It's just that so many people are infected, just statistically. Even rare events you will see. And because, at least up until now, most of us were very vulnerable to it, it gave the virus just lots of opportunity to get into new hosts and really kind of have a party in our bodies and replicate itself. And so just lots of chances statistically for mutations to arise. So I don't think it is that mutagenic. I think it just reflects the what happens at the beginning of a new infection. And I suspect, next time, if we have a next time, a new coronavirus comes into the human population, we'll see the same kind of crazy ride for a couple of years, and then things will start to settle down as humans, fight back with our kind of herd immunity and stop all these kind of crazy infections happening. But I may be wrong, but I don't think it's really that mutagenic. It's just numbers at the moment. Yeah.
Thank you.
Any other commissioners? If not, Professor Cannon, we're thrilled that you came today. We're really honored that you give us your expertise, your knowledge, and on behalf of the people of the City of Los Angeles and the Commission, we're thrilled that you're here. If there is interesting data that comes out of your lab or that you're aware of, please send it to us and our research associates. We make an annual report to the City Council, usually every December. We like to update with the most up-to-date information and keep it current. So please feel free to reach out to us. And if some major aspect change occurs, please let us know also, and we'd love to have you back because you're great. Yeah. Thank you.
Well, I really hope you don't see me again then, in that case, much as I've enjoyed myself. Thank you for your attention, everyone.
Well, thank you.
Thank you.
Moving back to our agenda, now that we have had a quorum for some time, I'll reopen public comment. Is there anybody here for public comment? Seeing none, we'll close public comment. We'll then move on to approval of the minutes from the August 14th meeting. If you were absent for that meeting, please vote to abstain. Can we have a...
Yes, and I just wanted for the record, we did achieve a quorum at 6:17.
Okay, thank you.
And Rita, you don't need a roll call. Just say all in favor, because we don't need to,
Okay.
because we're present.
So all in favor
Do you
of
need a motion or
approving
not?
the... I'm sorry?
He needs a motion. A
Is-
move
is-
to approve.
Is there a second?
Just a small correction on the minutes.
Please.
On page 2, in the summary for Dr. Shover's presentation, end of the third line, it says the word addition. It's a small spelling error, should be addiction. Thank you.
Thank you.
Yes. Thank you for picking that up. I missed that. So with the, with that adding of the C correction, Commissioner Kato, will you,
Move to approve, yes.
is there then a second?
I second.
Thank you. Any other comment or questions about the, seeing none, all in favor, say aye.
Aye.
Aye. Anybody opposed?
No,
Abstaining?
abstain.
Great, it's approved. And then, for future discussion, Commissioner Shannon, you had some good news that you wanted us to be aware of.
Yes.
You want to publicly
Yes,
announce
and
that?
Yeah,
Your
and
hard
I
work?
also wanted to bring up an idea for a future meeting for presentation. Anyway, the good news is that we have a $5,000 grant to print our commission report, and I can get some quotes on how many we can actually print out, but we can definitely print out for all of us, all of the council members, and then maybe a lot of the elected officials, you know, from the Assembly and Senate and Congress in the city of LA.
And the five supervisors'
And the 5
office.
supervisors.
That'd be
yeah.
wonderful, thank you.
That's important.
Excellent, great. And then suggestions for?
And then I would like to hear from LAUSD on what they are doing to address the increase in COVID infections at school. I find that a lot of parents are sending their kids to school kind of sick because there's actually a lot of pressure on parents to have good attendance record for their kids. And I would just like to hear from LAUSD on how they're addressing COVID infections. I know in my daughter's school there are a lot right now, including like almost half the 8th grade ended up being infected with COVID, and it affected field trips and other things. But I feel like I would just like to hear how they're communicating with parents on how they're monitoring children and whether or not they're too sick to go to school.
I think it's wonderful. I think we could work on that for the November meeting. The October 9th is a city holiday, so our next meeting will be October 16th, and that agenda is, for the most part, extremely full on gun safety. And so I think we could reach out to both LAUSD, but also to the county, because they have a chief medical officer of the county in charge of education. We can reach out to them as well. We've had communications with them both in July and I believe August of 2020. So we can reach back out to those people and invite them to come here. I think that's a wonderful idea. Thank you. Any other suggestions? Seeing none. City Clerk, yes, please.
So I just wanted to just reiterate, if any of the commissioners have any ideas in terms of the the gun violence and mental health topic for next month's meeting that Commissioner Cato worked on with Councilmember Park. It's still, it's still being kind of put together, and it really is mostly being done with the intern, with the research associates. So if you have any ideas of exactly what you'd like to see covered by the folks, I emailed you all a list of the folks who were invited and who has confirmed so far. And if you have any contacts, any folks that you think would be good to be invited as well.
And you're in contact with the senior advisor, right? Jacob
With
Berman?
Jacob Berman, yes.
Okay.
Great. Any other ideas? We're always open. If you have ideas, send them to myself or to one of the research associates or to Rita, and we'll try to get people here to educate us. Any other comments? If not, is there a motion for adjournment? Second?
Second.
Any discussion? Seeing none, all in favor?
Aye.
Anybody opposed? No, we're adjourned.